Alright, what's up guys? In this video, I'm going to pick up with some multivariable calculus, and we're going to be talking about double integrals and iterated integrals. So as to evaluate the double integral over the region R by converting it to an iterated integral. So really all we have to do here is just set up the double integral and evaluate it basically. So we're given this double integral, again, R is the region, x plus 2y dA. And then we'll have our limits here where x between 1 and 2 and y is between 3 and 4. So all we got to do is set it up and evaluate it. So we got our double integral. Again, R is the region, so it's just going to be x plus 2y dA. And this is integrated dx dy. So since it's integrated dx dy, then that means that the limits for the outer integral here need to correspond to y. So that'll be from 3 to 4, from 1 to 2, and then we got our x plus 2y, and this is dx dy. So remember how you evaluate double integrals. You evaluate, in this case, with respect to x first, treating y as a constant, and then we integrate with respect to y. You work your way from the innermost integral to the outermost one. That's kind of how it works. And again, I'm going to be doing it in small incremental steps. You don't have to do it the way that I'm doing it. I'm just doing it this way for the purposes of the video. Small incremental steps. So really what this is the integral from, I don't know why I keep saying 0 to 1, it's from 1 to 2, sorry, for x with respect to x, and then it's going to be plus the integral from 1 to 2 to y with respect to x. So in this case, from 1 to 2, so that's x squared over 2. You sub in the 2 first, then sub in the 1 after that, and that should give us 3/2. The integral from 1 to 2 for 2y with respect to x, well, not only is the 2 a constant, but so is the y. So in that case, that'd be 2y times x from 1 to 2, or when we sub in the 2 first and then we sub in the 1. And in that case, that's just 2y. So that's what we get for that. So now we move to our outermost integral, and we're pretty much already done. Or no, we're not already done. We're close to being done. And so now what we're integrating is the constant 3 over 2 plus 2y integrated with respect to y. And again, this is the integral from 3 to 4 for 3 over 2 with respect to y, and then plus the integral from 3 to 4 to y with respect to y. Okay, so let's do it. So we're integrating a constant here with respect to y, so that's just 3 over 2 multiplied by y. We sub in the 4 first and the 3 after that. So if I subbed in the 4, that would give me 6, and then if I subbed in the 3, that would give me 9 over 2. And 6 minus 9 over 2 is 3/2, so this is just going to be 3/2 as well. And then this one over here from 3 to 4, we got 2y dy, so that's 2 times y squared over 2 from 3 to 4. And so we would sub in the 4, and so that would just give us 16 over 2, which is 8. And then if we subbed in the 3, we get 9 over 2. And 8 minus 9 over 2, I believe, is 7 over 2. But we would have to multiply that by the 2 that we took out, so that would be 2 times 7 over 2, which is going to be 7. So we'll get 7 for this. And that's what we'll get. And so now what we do is we just take our 3/2 and we multiply it by 7. Or not multiply it, but we add it to 7. And I'm going to check just to make sure my arithmetic is correct here. And we add that to 7. Looks like we'll get 17 over 2 in my calculator. So that would actually be your answer. So your final answer, once we set up the iterated integral in this case, we were asked to evaluate the integral over the region R, x plus 2y. And when we did the integration, we got positive 17 over 2. So that's your answer. All right, pretty straightforward. That's how you do it. Let me know if you got any questions. We'll talk about it further. I'll see y'all next time.